So, yeah, I've been asked to talk about data from space. So, obviously, I guess you all know who we are. We're trying to get data from space. We're trying to help you guys get data from space, but we're also trying to get our own data from space. So there's obviously more than one aspect to Alba Orbital. I guess you guys know us as the launch providers, but hopefully we hope to get known as the data providers as well. So about me, you probably don't want to know a lot about me, but this is me. I've been with Alba for a good while now, so Tom keeps plying me with interesting work, so I keep on sticking around. I started as a software engineer. Ended up bug fixing hardware because the software wasn't ready. Sorry, the hardware wasn't ready, so I couldn't really write software. I always spent about maybe 10% of my time writing software. Fixing hardware on Unicorn 1. I moved to working on the ground station. I was building the ground station from scratch. I was doing the radio work, comms work. I spent some time doing manufacturing. Spent some time helping out with managing the engineering team. At the moment, I'm doing sort of ops and manufacturing, while Tom's sort of standing in for the engineering manager. So basically, yeah, I've done a whole load of stuff. It's been a real good adventure, and it's long may it continue. So let's see, data from space. So how do you get data from space? So it turns out it's not that easy. So that's what we found, but I'm sure that you probably find that as well. Unless you're Hungarian, they seem to find it easy. So you need a satellite, you need a ground station. Oh, there's T-Bone there. Ground station and a rocket. So we built everything. Well, okay, we didn't build the rocket, but we do the ground stations and we do the satellites. So there's a ground station. We've got a ground station out in Germany. Berlin. We use Germany because it's better from a sort of regulatory point of view. So we tend to do all our well, basically it's just a lot easier for licensing. You know, they sort of say fire it up. If you want to do it from the UK, it's a lot more complicated. So the Germans have been very good to us. We end up always getting ground stations out in December. We always sort of seem to fly in December, so we're always out there freezing, you know, absolutely freezing in the middle of the night. At least it's light there. Usually it's dark as well, so dark and snowy. You just need a good pair of socks and you're basically good to go. So we've built our unicorns there as well. That's three of the latest unicorns. So yeah, the ground station, let's see, back in April 2020, that's actually the iteration before that one on your left-hand side there. We used to actually build the ground station every time we wanted to operate it. The first one was like poke the antenna outside the window and see if it works. Then we didn't have a place for the ground station, so we would build it up every night and do a pass and then unbuild it. But we found a place in a car park quite close to us, which we were able to hire some space there. So that was the first iteration with the professional-looking tarp. But it worked, you know. And let's see, I think we were able to get signals. We were able to receive on that ground station there. So we made it look a little bit better in the second picture, and then we had to obviously move to Germany to do transmissions. So the bottom one there in Germany, that was sort of just the first time we opened the ground station site there in Germany. There's one of our. He actually should have. He should have found our satellite for us because he was actually Hungarian as well, so he should have found it easier. But he was a good guy. That was Bent. That was one of the first ground station visits that we made out there, and I'm pretty sure, yeah, we made contact with the satellite from that trip there. And then there was sort of upgrades later on, taking us up to March 2025, taking us out into the sort of winter wonderland, and that is the current state of the ground station at the moment. You see it's got a receive antenna and a TX antenna, Yagis. At the moment, we've not got the S-band functionality, but we do have S-band functionality on the satellites. So the ones that are flying, one of them's got an S-band on it. So at some point in the near future, we'll be towing. We hope to build another one here and then tow it out. And we hope to have two on site as well, because obviously if you're not hearing from your satellite, it could be your ground station or it could be your satellite. So if you've got 2 ground stations out there, then at least you want really at least 2 ground stations to do satellites when you're sort of doing these sort of early prototype stuff. That's going to improve your chances of success. So that is, March 2020, basically taking us through from then to now. TX signal, we detected a TX signal from one of our early Unicorn 2 satellites. So we were able to verify that it was still alive after about 3 months, and that was like sort of 3 months of building a ground station for the first time as well. So it was a pretty momentous occasion when we actually discovered that our satellites were alive, and were actually talking to us and responding to our ground station. So March 2022, we got U2D up, which is still quite an early iteration. We got some telemetry, and we got some telemetry decoded, which was pretty momentous as well. So maybe a year and a half later, we actually got our first images downloaded from U2N. The telemetry was good quality telemetry. We got a lot of telemetry out of them. We kept one of our satellites. We were able to keep it live for 30 days. The images, we had issues with the optics. We don't still know, it's not conclusive, we don't know exactly what they were. We've made a variety of upgrades to the optics and the testing procedures, and also to the stability of the satellite, battery heaters and things like that, which I'll go into later on. So we're hopeful for the next flight, which is 2 weeks-ish from now. So we'll see how they go. And we're confident. We're certainly hopeful that we'll get sort of decent images this time, and that will be the best progress so far. So there is 2J and 2K. So the latest flight that we sent up, well, not the one that's just about to launch, but the one previously last year. Let's see, we sent up 5. So we got J, K, L, M, N. So we sent up J and K together, and then L and N flew like a month or so later. So that's them there. J. So we've got the negatives first, but I'll go over the positives first, right? So we got 10. We ended up with 10 pictures from U2J. So it was pretty sickly. Like it lost a wing electrically. So before it went up, we discovered that was an issue, and we reflowed the wings. We think it was maybe a dry solder joint somewhere. We thought that had done the job, and it may have done the job, and it may have been an issue with the other wing, which we hadn't sorted. But certainly we lost a wing, but we were able to get it in really low power state. We held down the radios, because the radios are pretty power hungry on our satellite. So we held them down, and we were able to keep it alive for, with a bit of manual intervention, for about 30 days without resetting, which was a lot better than before. Obviously it's not as good as some of T-Board satellites, but it was certainly progress from the previous flight. So yeah, it was an intermittent issue, so it's difficult to know still. I mean, we've always, basically you're obviously always testing and improving stuff. So we still need to do more delving and improving on the wing design. But we certainly hope that they're going to be better on the next flight. So so there's a lot of positives. The plot that you see there, that was an issue. That's the issue that we've had, which we've been dealing with the thermal issues. So a word of advice: don't put your batteries on the outside of your satellites. It's really not a good idea. Like, just don't do it. I mean, somebody pointed out to me, asked me last night, why are your batteries still on the outside? And it's like, well, yeah, I know. I know. They shouldn't be on the outside, but they are. But we have, so in order for us to move them from the outside, our satellite is so compact, and it would need a complete revisiting of basically the whole thing. So for this flight, we've not moved them, but we have improved them. We've put on a cover, we've put on multi-layer insulation, we've got some aerogel in there, we've got battery heaters on there. So we're trying to do, we expect them to be a lot better. We've done thermal simulations as well. We've employed some thermal simulation contractors to help us out with that. So we're certainly hopeful that it will be better. But yeah, if you've not like designed your satellite yet and you've not put your batteries on that side, don't do it. You know, it's not a good idea. So you see the voltage collapsing. The blue line is the voltage collapsing over the umbra. So that's basically over one orbit. So you can see it collapsing right from 8.2 volts down to sort of 7 point, nearly down to 7.6. And that's enough for us to, well, on that one, we've got telemetry all the way through, so that's not going to reset. But once we go below about 7.6 volts, then it's going to start resetting. You know, and that is just purely battery related. So once we saw that, we replicated that in the, you know, on the ground. I got them in a freezer, and we discovered that, you know, that was what the issue was. We're concerned about sort of plating as well. In fact, I think that's on the next slide, so I'll go through the next slide. So this is U2K. So this is the one that went up along with J as well. So you sort of, I'll go, you know, sort of summarize it. In fact, this is, so it ran for 2 weeks. They often come back, with that temperature issue, they would often come back. But this one was basically, it just disappeared. It was doing really well, and then it just disappeared. So, you know, we've got a few guesses about that. I mean, it could have been a radio PA popped, or, you know, it could have been a variety of sort of catastrophic failures. But we think that probably the best guess is a battery short, because we were trying to charge it in cold temperatures as well, because they were getting so cold. So that was growing little dendrite growth, which can, you know, pierce your battery, and you basically end up with a short internally in the battery. So that's complete loss of power. Because the Unicorn has a high sort of charging current peak because of the 4 wings. Because of the eight modules. If you couple that with cold temperature, then, you know, you can end up with these dendrites growing, and just basically, your battery's going to short at the last, you know, at sort of any sort of indeterminate point in time. So, I mean, that's what we're guessing, which is why we spent so much time trying to improve the batteries without rebuilding the whole satellite. So if we go back to there, this is the telemetry from K. So you can see on the far left, that's basically our uptime in seconds. We've got the interesting column is probably the battery voltage there, which, you know, basically shows you that we're getting a decent high voltage up to 8.420 in the middle there. That shows us that we are charging, you know, fully charging. So they're all up above 7.8, 7.9, that sort of thing. So that is good. We've got in the middle there, we've got 546. That's when we're actually charging the battery. All the reds in the bat eye column. That's when we're discharging the battery. So it was basically looking great. It was looking really healthy. It was looking super, well, pretty damn cold. Like, that's the minimum temperature in the blue there, and that's the maximum temperature in the orange. So it was looking pretty damn cold, pretty damn hot. But it was looking okay, and certainly the battery was charging, and then it just disappeared on us. So. As I say, this was some kind of catastrophic failure. It could have been a radio PA or something like that, but we think potentially it was the batteries that killed us. So we spent some time trying to improve that on the next ones. So LMN, what time am I on, by the way? How are we doing for time? Well, spent 15, just talking, okay. LMN basically launched them in December 2023, just after J&K. That's me and Tom there about 2 o'clock in the morning. We're trying not to work at 2 o'clock in the morning, but sometimes it happens, right? So, I mean, that's the sort of, well, I'll actually skip over that side, right? So this is U2M. Again, so we had LMN. L was dead on arrival, basically. We never heard from L, which is sad, but let's move on from that. U2M. The wings didn't deploy. So we can tell from the ballistics, if I go to the next one, tell from the ballistic, you know, from looking at the TLEs, the ballistic lifetime was a lot longer than U2N. So we can tell that the wings never opened at all. So we heard from it for a small amount of time, just while obviously the battery kept it alive, but it never charged it up. So, you know, it died after a few days. So basically, you can see from the bat V column there, it's just going down, 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 down. There's a few erroneous ones there, which I think are just erroneous. But yeah, you can see it going down, 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 and eventually we just lose it. So U to N. So N was a relative success. We got a personal best for cold temperature, so that got the batteries got down to -38 there. So that's pretty damn cold. Again, don't put them on the outside. And we got some photos. We got probably about 8 or 9, 10 photos or something like that from U to N, which was good. So this one was coming back. Again, it had intermittent resets because of the battery temperatures. But obviously the photos as well that we got were basically just blurs, you know. So there was something, we reckon something went kind of catastrophically wrong with the optics as well. So we don't know exactly what it was, but we think potentially the IR filter, we had an IR filter on the lens, and in testing on the ground afterwards, maybe the IR filter was come disattached from the lens, because that sort of significantly affects your focus. So we think that potentially that was the issue there. So OP and Q, this is our next ones. So what do we do? Obviously, one of the sort of key things for Alba, one of the key constituents for our testing is getting in-flight data. You can do so much on the ground, but then the most valuable test data comes from actually flying your satellites. So clearly we know that there was issues with the thermals. Clearly we know that there was issues with the optics. We need to improve our ADCS as well, because that wasn't well tested in the last flight. So yeah, thermal redesign. We've got aerogel. So the shiny foil case there that you can see. So that's layered. We've got what is it, 𝗖cieः 𝗁. I think that's an 𝗖cieः 𝗁 milled cover, and then we've got aerogel inside it. We've got a variety of different layers inside that, and then on the outside as well. We did thermal simulations of that setup, and it looks on the simulations that it's a lot better than what we had before. So in 2 weeks, we'll see if that is correct. The optics were a lot more rigorously tested than before, and we added some capped onto the antenna as well to reduce reflections onto the lens, because we think that potentially that could have been an issue. More testing, they're launched. That's one of our test images there with the crane, basically just taking an image of a far off distant object, and even that is better than some of the testing we were doing before. So that's us. I think there's another couple of slides. Yeah, just a word about the new facility. I don't know if, I guess some of you have seen the new facility, some of you who were here last year. It's just a hell of a lot better than the facility before. We were spread out on sort of 3 different sites. Now we've got a warehouse, we've got a manufacturing space, we've got office space, we've got space for manufacturing ground stations as well. So it makes the whole thing a lot easier. The manufacturing space is larger than it ever was before, and it's better integrated with the engineering department and stuff as well, rather than being on its own sort of little trek through the building. So we've got better workflow, a lot better communications between the different departments. We've got office space, again, having designers next to all the manufacturing area, next to the ground stations is just a whole lot better for communications. We've got our ground station assembly area, which is better than sleet and storms and -10 degrees C. It was pretty damn cold when we moved in, but even that was better than sleet and snow. So it is all good, and that is, I would say, that's how you get data from space, basically. So work hard, make some good satellites, make some good ground stations, and do your best. All right.